Very good evening.
Good evening.
Good evening. It is very nice to see you all this virtual platform. Now this time, HSE Forum Kerala is bringing a new stream of knowledge sharing, slightly deviating from our regular safety-related topics. Today we have an eminent personality, Mr. A. Narayanan, to talk us on green building, its concepts and its components. May I request Sri P. Nayan Kumar, the convener, HSE Forum, to commence this program with his welcome note. Over to you, sir. Please.
Thank you, Radhakrishnan. And good evening to all the participants. Good evening to Mr. Narayanan. Climate change is one of the most trending hot topic of discussion today. There is very urgent need to reduce our carbon footprint, initiate very stringent measures to control the emission to ensure that our planet remains sustainable. We are all experiencing the ill effects of the climate change past few years, but actually this is all nothing as compared to what the scientists are saying about the impending disaster that is waiting to happen. The mankind is facing the biggest challenge of survival, and the only way to overcome successfully is by working together. Nations have to come together for reducing the emissions and carbon footprint. Not only the nations, the society should come together, the communities also should come together, and more importantly, every individual should be firmly committed to sustainable actions. It calls for relentless discipline to reduce, reuse, recycle, and repurpose, the 4 R's to save this earth. And therein comes the relevance of adopting green building concepts. As Radhakrishnan mentioned, I think this is first time I think possibly HSE Forum is coming forward to have an evening talk on sustainability. It does not mean that we have forgone the safety talks. We will also have a safety evening talk this month itself by an expert on the topic. But parallelly, we would also have experts talking about sustainability. This is one of the first talk on sustainability related matter on green building. It is said that buildings, whether it is an office building or whether it is a residential building, it consumes lot of energy, lot of water, and generates lot of waste. As per statistics, they say building has been accountable for 28% of the energy related emissions in 2019. So it's very imperative that we all adopt the concept of green building. But how do we design a building which will consume less energy, which will consume less water, which will produce less waste, which will use more of daylight energy, which will use renewable, is all to be learned and incorporated. And to enlighten on this, we have with us an eminent expert, Mr. Narayanan AM, who is a past director of ANERT, Government of Kerala, and practitioner of energy projects and policies. Mr. Narayanan is an electrical engineer with masters in energy management. He has undergone advanced training in energy management in Germany and Japan and in project management in USA. Currently, he is engaged in special assignments in energy sector projects and policy. He is a certified energy auditor of Bureau of Energy Efficiency, Government of India, IES Indian Engineering Service alumnus, distinguished lecturer of IEEE IAS, and is actively associated with deliberations and implementation of Energy Conservation Building Code, and he left the drafting of Ecbc notification, including energy audit of buildings. His former positions include Senior Energy Expert under Bureau of Energy Efficiency for State Designated Agency. He was the head of Energy Efficiency Division at Energy Management Center, Government of Kerala. He was the Chief Operating Officer of Multinational EPC Project Consortium, USA and Middle East. He was the Director of State Electricity Regulatory Commission. He was also served up to the level of Director in Government of India in core sectors of Indian economy, including projects supported by UNDP and the World Bank. On behalf of HSE Forum and NSC-Kerala chapter, I extend a very warm welcome to Mr. Narayanan for this evening program. And also a warm welcome to all the participants who have joined for this program and for a enriching learning from Mr. Narayanan. And thanks to all the organizers who have made this possible. Over to you, Mr. Narayanan, to start off the program. Thank you. Welcome to all of you.
Thank you very much. Thanks a lot for giving an opportunity to interact with you. And since the time limit is 60 minutes, I think I will not go for any introduction. I hope my screen is clear now.
Screen is yet to come.
Is it okay now? Can
No,
you see?
not for me. I think I can
No,
see you, not your screen.
we can see you. Your PPT is not on, sir.
Okay, I'm going to download again. I'm going to upload. What about now?
Yeah, I think you can put it in presentation mode.
I'll do that. Is it okay? Is it visible, please?
It is visible, but it is not in presentation mode.
Now it is.
It's coming in. Maybe you have done it, but I think for us it is not coming that way. Maybe we'll have to focus it.
Something mine is okay here. Anyway, is it visible? I will start now.
Yeah.
Once again, thank you for inviting me for this session. So I will straight go to the subject. Since it is sequentially arranged, this presentation, I hope you will not lose a sort of slide in between. So it's titled as Green Building Concepts and Components. You can see two pictures I have seen here, shown here. One is a green building, the right side. It's a good green campus. Maybe somebody can tell which building is it later. And the left side is a disaster that has happened in a building. Here we are trying to interrelate disaster, sustainability, and green building compliance. So as our president is talking about the impact of building on the environment, you can see here, buildings are responsible for much more than I think what he told, but 38% of global energy related carbon. It's a UNEP report, United Nations Environmental Program. Their report is 38%, almost 40 now. And 50% of extracted materials, cement, steel, everything is natural resources. The natural resource exploitation is highly in the building sector. And this is a very well researched areas, two of them. There are a lot of literature available. Now, if you look to comprehend what sort of life cycle, in the life cycle of the building, there's a cradle to graveyard. We can say like that, but still the graveyard concept is not much in the case of our, what do you call them, case. The demolitions, the electric demolitions are yet to take place, but still we can see here, from the start of the site preparation, the damage starts. See, we have got the input and output I am clearly given, that's very comprehensively given. Site preparation, you can say energy is required in site preparation, both in construction as well as site preparation, like construction power, lot of materials. In big sites, we have got big mobilization, suppose you're talking about big industrial complex or a building complex, we need a mobilization itself is a highly soil and energy consuming thing. A lot of emissions, carbon dioxide, dust, noise, ecosystem wastage, ecosystem damage, a lot of waste generated. Then construction stage, there is no doubt that it is emitting a lot of carbon emissions, dust, noise and waste. So the emission, dust, noise and waste, plus some sort of maintenance waste, other domestic waste in the case of use of buildings. When you start occupying a building, energy is used for all appliances, systems, lifts, every sort of equipment used in the building. And waste is generated abundantly, both air, water, as well as earth pollutions. Then demolition is also an important thing. Kochi, people have already seen two great demolitions. But there are demolitions in cycle as well, that is after the end of life. Sometimes we do modification, modernization also. So this gives an idea. In another fashion, if you look at this, take a building. If you look at a building modeling of that, groundwater contamination, you look at the bottom line, groundwater contamination, effluents. Input of the building.
Just a minute. Is the slide moving for others? I am in the
No,
slide.
sir, your slide is not moving. The first slide itself.
I see.
Sir, I think you have to unshare and then when you
now it is moving.
go to the screen and then when you get two options, no? When you try to share, there is a screen and window. You connect to the screen and from desktop you upload, sir.
Okay, let me see. I will come back again.
You have to unshare and then reshare.
Is it okay now? So trying now?
No, no, sir. It is not a full screen.
Sir, you can unshare and then when you connect to again reshare, no, you will get a choice. You will have to choose the screen option. You're not unshared so far. It's still on the screen, your presentation. Now when you reshare, you have a choice either to connect from screen or from window. Instead of window, you should choose screen.
What about now?
It has come, but still not in presentation mode. But I think let's get going.
What about now?
No, sir.
Not moving now?
It is in the first.
The first slide.
Okay, let me try.
Maybe Radhakrishnan, if you have, you can also try to upload and then.
Shall I make the presentation?
Oh, then you do it. I will do the voice from
Yeah,
here.
fantastic. Yeah.
You go with the third one, please.
Now can you see the presentation?
Visible. Yeah, visible.
Okay, now I'll start talking, okay?
Yeah.
So you can see a building model in terms of what we talked on the first slide. You can say building, the inputs are fuel, material, waste, and you can see the exhaust going on as heat, smoke, dust, there's noise and pollution also there. The liquid and solid waste, soil erosion, and also that sphere you can see the interference with the environment, climate change, as well as vegetation, wildlife, etc. So this gives a very clear picture what sorts of impact a building can have, particularly a campus type of big building can have to the environment. So next slide, please. If you look at the buildings historically, if you look at it, native architecture, design and construction used to take care of the geoclimatic conditions of the building. So if you look at old buildings if you look at the historical buildings, everything were perhaps constructed, including the materials, with us of the geoclimatic seasons. They used to have wisdom of the local people for building materials, orientations, comfort content interior. I've given an example, which is a very, we can say, not a very typical example, like igloo constructed by the Eskimos. So with ice itself, they are making a house, shelter. Even for minus 45 degrees centigrade outside temperature, they're getting about minus 7 to 16 degrees inside. So this is more suitable to that particular climate, no damage of the building, no damage to the environment. But as the construction started progressing, a lot of standardization took place. We talk about strength of materials, then soil bearing capacity, then other safety standards, etc. So we become more standardized specifications, sometimes not looking at the performance with respect to the nature. So it becomes specification oriented than moving to the performance oriented. It started in the industrial revolution. So a lot of productivity improvement, profiteering. We couldn't take care of a lot of things connected to the environment. That's how sustainability came for the last 50, 60 years in a big way. So next slide, please. So now we are coming to the green building. And after understanding what the damage has been constituted by a building, come to the green building. A green building, there is nothing like a definition, but you can comprehend like this. A green building, you start even the site selection process. I put in the bracket mainly because there could be some constraint, because about 3-4 years back I had 45 cents land for a government building. They wanted a green building. So within that particular constraint, we have to design. That's why site selection sometimes will be constrained, but you can also incorporate that. Select the site, design the building, construct it, operate, maintain, etc., with an objective to reduce or eliminate negative impacts and to create positive impacts on what? On the climate and natural environment and ensuring the quality of life of the occupants. It's a very comprehensive thing and discuss it for a long time. But we have to understand what. When you say design, design means what? Design of the whole building envelope, building structure, building facility requirement, etc. And construction materials are there, construction methodology is there. Then operations of the building means how the occupants are going to behave, what sort of equipments they want, what are the activities related with the environmental impact. And negative impacts, we have already seen it, how to reduce it. Some of them we can eliminate, some of them we can mitigate, some of them can reduce substantially. And in place of negative, we have to create positive impact. So you can say about the reclaimed land, even deserts are going to be get turned into sometimes, big gardens nowadays. That's also reclaimed land. All negative impacts we can turn around to positive impacts, even waste heat recovery, etc. So for what? Climate and natural environment and ensuring the quality of life of occupants. What is quality of life of occupants? A building occupant, whether it is a housing building, house, or a factory, or a sort of big mall, the occupant's comfort or the quality is very important. The lighting, the ventilation, the healthy environment, etc. Even now the pandemic has come, we know much more now. We have learned a lot of things again. So apart from this, the most important, already a lot of rating systems are there in place. Like you have got the Griha, you have got LEED, you have got Ecbc, and also a lot of codes and standards like energy constant building codes, ASHRAE. So these has to be complied with. Always this codes, etc. helps us to meet the objective in all these stages. So I hope this particular 3-4 points are very important. Next, please. The next slide gives our next point in the discussion, that is the components of the green building, or what are the features which make a building green. So this is not a exclusive list, but you can add on this. But this comprises the major points. First one, preserve the precious natural resources, flora and fauna. You talk about the water body, you talk about the forest, all sorts of natural material locally available. You try to preserve this during this process of making a green building. Then whatever materials you are going to use for the construction should be non-toxic. For example, don't use like organic, volatile organic component in the paints or any other construction materials. It should not be toxic. Then sustainable means what? When the life cycle is over or even the operation period, it should not damage the environment. And indoor air quality. What is indoor air quality? When you are sitting in an inside of a building, whether it is a house or an auditorium, etc. We look mainly at the temperature, 25 degrees centigrade plus or minus 2 degrees, comfortable. Then we look for humidity, say 55% plus or minus some 5% or 10%. Then we look about the ventilation. Ventilation is air change, the number of air change we should have to maintain the purity of the air. Like we talk about carbon dioxide, the exhaust created by human system plus equipment operated, etc. So number of air, that is ventilation. And the fourth one is what? The impurities. We have got particulate matter, we have got carbon dioxide, whatever other toxic gases that can be formed depending upon the nature of operations. All these things are the one we talk about indoor air quality. Suppose you are constructing a building where the exterior quality itself is bad, when you are admitting that, you may have to even treat it, filter it. See, like you have seen the Delhi air pollution, etc., particulate matter. Even now, in our house, we don't clean for a day, dust accumulates. So IAQ is an integral part of the green building. Then efficient use of energy. Energy utilization in a building is one of the major elements. We have to use efficiently without sacrificing the requirements. Similarly, water. And what are other resources? We talk about any other resource, what? You can see LPG gas or that type of resources. Then adaptation to a changing environment. This is very important when you talk about the disaster resilience of a building. What do you mean by that? See, now we have got flood, we have got wind, we have draft. How do we construct or operate a building or design a building to adopt this changing is a challenge in the green building. And you go, people are going to Japan. You have seen when you go to Japan on an official tour, the first half an hour they give you a lot of precautionary things. And one of the things is when the earthquake comes, how do you manage inside the building? So they got a lot of systems to be followed. And for a small earthquake, nothing will happen to us. Only thing, we will become panicky and we can escape very happily without any problem. So similarly, their flooded area, like construction in Olympi or Venice, etc., when we see water, we don't become panic. But when it exceeds certain level, how we have to encounter those type of disasters, it's a challenge. Then pollution reduction and waste management. Pollution means air pollution, water pollution, earth pollution, whatever you dump there, as well as waste, solid waste, liquid waste, bio, incineratable, whatever it is. Buildings generated, how do you use it, how do you manage it, and reuse and recycle. Reuse and recycle is very important. Recycle can be external as well as internal. Internal means you talk about water recycle and use for the garden purpose, etc., or even portable quality. The reuse is now even clothes and materials and furniture. There's a trend even in most developed countries to reuse, repair and reuse, and harness renewable energy. In the building, we talk about renewable energy in a different way. See, we can talk about roof-mounted solar. We can talk about in the way biogas, etc. But now this itself, the building integrated photovoltaic system, a lot of technology solutions have come to enhance the harnessing plus integrating with the grid, storage, standby islanding, etc. So these are the components, and the earlier one gives you the definition. The components and concept basically is clear to us, and we are moving on. Next slide, please. Now, this gives you a very comprehensive picture of a sustainability of green building. Sustainability, you know very well, there are three elements basically: social, economic, and environment. Suppose you build a building socially, it should be acceptable for the people who are using it, for it should be inclusive. When the people are coming to the mall, whoever is coming, irrespective of their income, etc., or caste, creed, religion, social status, they should be feeling comfortable. It should be good for the society, living people surrounding, etc. Plus, it's inclusive. And economically means it should generate some sort of revenue, not negative. Or in terms of revenue means it could be benefits also. Some of the benefits you cannot quantify in terms of rupees. And this social and economic thing should be enveloped by the environment. It should not damage it. That's what is sustainability. So let us start from any point. I will start on the bottom on design efficiency. We have already given some introduction. We will go in a bit detail now. The resource efficiency. Resource means natural resources and whatever you use inside. Then material, construction material, a lot of wastages in the construction plus whatever during the process plus demolition. Then reduction of greenhouse gases. Already the building as such won't generate the greenhouse gas unless you do some primary energy conversion inside the building or some sort of greenhouse producing activity. Otherwise, it's all secondary things, like as a result of you are using the building, people are coming there. As a result of your building is there, you are using electricity not generated from your building by fossil fuel combustion, but from the electricity authority or the distribution company, which has got a carbon mix. So that is, there is a scope 1, scope 2, scope 3. I'm not going into the detail. That's how we calculate the reduction greenhouses. For us now, let us talk about the electricity used versus the footprint of electricity. Then indoor environment improvement. We talk about the air quality. Apart from that, we can make much more important. Then generation of energy and distribution. The generation you mostly do for contingency, sometimes diesel generator, etc., which should have efficiency and all those things, safety and efficiency hand in hand goes together. When you're talking about the renewable energy, maximum harnessing, maximum utilization. Then energy efficiency, again talking about the appliances and systems. What is the appliance and system is what? If you have got a very efficient appliance, for example, say you are using a very efficient motor pump If the motor is inefficient, the system efficiency will go down. If the foot valve is bad, efficiency will go down. If the pipeline friction loss is high, then efficiency is good. If the water use is bad, water is not used, that's bad. So you have got two efficiencies. One is equipment level efficiency, then component efficiency, like valves and fittings or whatever it is. Then third one is the whole system you have to consider. The glass of water you are getting versus the power input to the motor. The land use efficiency. The land use itself is a UNFCCC big item. In land use, you can search for that in the United Nations Framework Convention Climate Change. Land use itself is a big thing, particularly concerning buildings and urbanization. Then water efficiency. Water efficiency is where you get water, how you use it, whether you recycle, are you harvesting rainwater, etc. Then comfort efficiency, whatever comfort conditions we are going to have, whether it is a grill, that is a food park, up to HVAC system we are using, all these comforts are required to large extent, complying with the standards, but are we using it efficiently? Then waste management efficiency. Waste management is one part, waste management efficiently in part. Then overall building management. So all this green circle we have to meet in one way or the other with its own technology, management and operational strategy. Next slide please. So having understood this batch, we have to look into one aspect. Any people ask which building should be green building. Any building can be green building, right? If it includes all those features what we discussed. If we can include those things in the site selection, in the design, construction, operation, we can make any sort of building, whether it is a mall or a small house or even a big university campus, everything. But approach to green building may vary depending upon country to country, region to region due to various characteristics. The building I am making in Miami Beach is not the same I am going to make in Idiki. Both can be made green, but a lot of criteria will change because of the climatic conditions, geoclimatic conditions change, and the cultural traditions change. Sometimes we have to retain. Like the conventional architect, what we use, Kerala architect, we can make it green. We can use the same aesthetic. And if we want to retain some of the heritage building, we can turn it around. Then the type and ages of the building. Suppose we want to make an existing building green, we have to consider all these things like heritage building. See, I have seen two figures here. One is the climate, how it behaves, bright and dull climate and scorching sun. And you can see the agraharam type of construction. I'm giving a challenge to you whether we can turn them to green building. So, depending upon the economic and social priorities, this is a bit policy related thing. What is economic and social priorities? Economic priorities, for example, we are having life mission. That's a good example actually. How are you making it economically acceptable and socially acceptable, inclusive? There comes the social property as priorities actually. We need to give a house, it should be comfortable, cost affordable and environmentally sustainable. So these are some of the special aspects when we come to the construction or the design. Okay, next slide please. Now let us start let us understand all these components what we have discussed. We'll start with energy. See, energy, a green building, as you know very well, is one of the heart of the system is optimizing the energy efficiency. Or we can talk about an intelligent approach to energy efficiency. First one is minimizing energy use in all stages of building's life cycle. When we talk about when you got a building, you started occupying it, that is the use of building, utilization. But I'm talking here from the site preparation, when we say mobilization for construction, and site survey, layout, so many things up to the demolition. All these phases we have to talk about energy use minimization. When you say minimizing, not sacrificing the requirement. If you want to use a jackhammer, you need a compressor. When you want a compressor, you need electricity, or a diesel engine, whatever. But how do you do that? Like it depends upon what is the pressure, what's the soil you are using, etc. So there are components and operation strategy where you have to optimize this energy efficiency. Then integrating the renewables. Building integration with the renewables is in the building campus itself. How can you do this? You can have somewhere else and do it, but it is not coming directly to the green building within the building campus. Then energy efficient appliances systems. And nowadays, for the last 20, 30, 40 years, many countries are coming out various schemes. But now for the last 10, 12 years, there are mandatory standards, including in India, like star labeling system, etc. We can identify which are the efficient materials or efficient appliances in the what you call it available in the market. Suppose you want to buy a sort of lighting apparatus, or you're talking about an HVAC system. There are labelings available to identify the energy efficient appliances. But even if, as I told you, an appliance is efficient, your systems also should be. Suppose you take a cooling tower, a lot of cooling tower available with high, what is a very good range, very good approach, etc. But if you are not incorporating with the good pumping system, the whole things will go down. So system approach is required when you talk about optimization. The low carbon technologies. See, low carbon technology you can start even with the entertainment, this ICs, that is your information communication sort of things what you're using in a building. Even that has got to be efficient. And up to any other, like you would talk about a hardtail, you got a lot of appliances, even in house, big complex, we got a lot of. So all what we use should offer low carbon means emission by that appliances of the system, but mostly it won't happen in a building. It will be its efficiency contributing to the exceedingly high consumption of electricity, and electricity has got its own footprint. For example, in our state, 30-40% maximum we are getting from hydel, balance is from the thermal power plant. So around 0.75 to say almost 0.85 kilogram of carbon dioxide per unit in Kerala itself we are emitting. That's indirect, but that's we are accountable for that. So all these points are the one which we have to consider in a green building life cycle for energy optimization. Next slide, please. So when we talk about the energy efficiency of a building, in India, we have got a code called Energy Conservation Building Code, Ecbc, published in 2017. And based upon that, already there is a rule published by Government of India 2018. And in Kerala also we published a Energy Conservation Building Rule in 2007 code. Ecbc is 2007 code based, but is getting amended now to suit to this particular thing. And you can download it and see what is the technical code actually. This code is actually put up based on Energy Conservation Act. For energy efficiency enhancement, an legally enabling provision has already come in our country in 2001, which is called as Energy Conservation Act. This Energy Conservation Act talks a lot of things, mandatory, voluntary, in building what we should do, industry what we should do, etc. In section 14P of this particular Act, Energy Act envisages to publish something called Energy Conservation Building Code, and it has been already done in 2017. We have to mandatorily adhere. And what sort of buildings are coming under this Ecbc? All sorts of commercial buildings. Ecbc is not addressing the factories, not the houses. It's for the commercial building. വാണിജ്യ അടിസ്ഥാനത്തിലുള്ള ബിൽഡിങ്ങുകൾക്ക് വേണ്ടി മാത്രമാണ് ഇതിപ്പോൾ വന്നിരിക്കുന്നത്. പക്ഷേ there's another called Eco Samhita, which is for the housing sector. That Eco Samhita also you can download, but that talks mostly on the building envelope. Now let us go concept of what is this Ecbc. Let us move to the next slide, please. I hope slide is moving now. Hello.
Yes, now it is 11.
Slide 11th ആയി 11th slide ആയി. Correct അല്ലേ?
Correct. It is in
okay.
11th slide.
Okay. So what I am showing here, I talked about Ecbc. When a code comes, it should be empowered. It is already published as a result of an act. Now when we got it's called acting an act or a rule to be or code to be empowered means there should be legal provisions. You can see here Ecbc has been integrated in rating and compliance system. Following very important 3 components. One is environmental impact assessment. EIA is done for large buildings, large campuses. What sort of damage you are making to the building, to the environment by the building. So this has been supervised by the Ministry of Environment and Forest. I have shown that MOEF emblem for comprehending correctly. And this ECBC is actually coming under Ministry of Power, Government of India. This Government of India organization or the entity looking after the implementation at Government of India level is Bureau of Energy Efficiency. And in every state, for Bureau of Energy Efficiency, there is something called State Designated Agency who is responsible to implement the Energy Conservation Act in each state. In case of Kerala, it is Energy Management Center. In Karnataka, it is Karnataka Renewable Energy Development Agency. Tamil Nadu, it is Tamil Nadu Electrical Inspectorate. So many like that in each state, different agencies are implementing this particular act. So under that act, ECBC comes, and ECBC has to be in our state implemented by EMC. So where are the provisions of ECBC mentioned? Like I told you EIA, Environment Impact Assessment, it is embedded. Then you all heard about the Griha rating system. Griha actually is operated by the Energy Resource Institute, but MNRE has got a hand in that, Ministry of Renewable Energy, New and Renewable Energy. So Griha means Green Rating for Integrated Habitat Assessment Rating System. In our Kerala also there are a lot of Griha certified professionals, and in that also energy optimization means ECBC is referred to. Then you know IGBC very well, Indian Green Building Code. In Indian Green Building Code, as well as in their system is LEED actually, Leadership in Energy Environment Design. ECBC is the heart in case of the energy efficiency enhancement. So ECBC is integrated in all these rating system, plus most of the state government in India has already made it as a rule for a particular capacity and above commercial buildings has to be designed, constructed and operated according to this particular code. And now let us see next slide, what is this code about? And this is very looking bit complicated but easy to understand type of thing. I have shown the building here. Let us start from the one corner, so left hand bottom. See the first
slide has not moved, sir.
Slide has moved?
Not moved. It is still in on 11th slide.
You can go to 12, please. Is it okay? They are moving from there. Yeah.
No, it is not moving. Okay, let me try.
Otherwise, sir.
Okay, let me see. Okay.
Video.
Okay, now it is 12.
Okay. This is actually, this particular slide shows ECBC in a very understandable form, even if it looks like a bit complicated picture. You look at this building and start from somewhere. Let us start from the left hand box. See, I have shown here energy efficient lighting with control. So ECBC looking at the lighting. How are you using energy for illumination system, lighting the inside and outside the building? And what sorts of controls you have there to suit to the natural light entering to the building, plus occupancy of the building, etc. That is energy efficient lighting with controls. Then low conductivity walls. Next box, you can see that low conductivity walls means what? A building, when you talk about comfort condition, should not gain so much of atmosphere heat from the sun and get heated up. But it happens. But when it heated up, it should not transmit the heat directly inside the building. So what you should have, it should conduct slowly. Suppose it is very, say, 11 o'clock, very high temperature, 30-40 degree outside. It should delay the conductivity. How do you do that? By insulation or shading. That's why low conductivity wall. That wall material matters here. It's called the conductivity, that is U value or the resistance, insulation value of the building envelope or the walls. Go up. Low conductivity roof with reflectance. Even in our house, when you go to some apartment or a house, in the evening after our office hours or working hour, it looks like a furnace actually inside. Because why? With all the heat inside is there mainly through the roof or from the walls, south facing walls. So if your roof has got good reflectance, what will happen? The sun rays, the heat wave will go away. As well, if the conductivity is low, it will not conduct internally. So your roof design matters here. And another one, skylight. In big buildings, we have got skylight for illumination. This also should not penetrate much heat, but only light. How do you do that? Admit only light, less heat. How do you do that? There is something called solar heat coefficient. This particular type of HSE rating is available for certain glasses and material. So for low HSE means low amount of heat inside, high amount of light towards inside. So that type of rating has to be followed. Then solar water heaters means, so any building, particularly hospital, etc., even campus, we have a lot of requirement of hot water. So hot water you use mainly only the solar water heater. Don't try to do other one. There's a stipulation at least 20% of the hot water requirement must be by solar water heater as per the Ecbc. Then Hvac system, one of the major energy consumption for centralized or other buildings are Hvac. So efficient Hvac system, your chiller, your condenser, your cooling tower, everything, and the whole package. Then energy efficient glazing with low conductance. Glazing means your walls, windows, shade, etc. should not admit particular quantity, more than particular quantity of heat inside, but maximum light. So high vertical light transmittance. So visible light transmittance. Visible light means what? Light should be admitted as maximum as possible. If you look at the old building, that's one of the some of the heritage building like bungalow, you go like Munnar and all, sometimes you see at top level they put lot of ventilators that can illuminate with daylight the whole area. So that is VLT, that is visible light transmittance has to be increased. Then advanced metering means what? If you got a building, like you could take your software park or techno park or even big mall. Somebody asks how much is the Hvac consumption? No idea. What's the maximum demand due to lighting? No idea. So we should have sufficient metering to monitor and audit our energy utilization pattern. That's why metering is required. When you go for a smart building, you have a lot of control integrated with the metering. Then I have shown here the transformer. You can see the transformer itself is an apparatus which has got its own efficiency. Electrical engineers, they love transformer efficiency too much. You can say we can get even 99% efficient transformer for higher capacity, power rating. But in domestic or small building transformers, something like 92, 97, 99. So this is to be important. This is an important area because always there will be losses. So you go for a high efficiency transformer, and these are the major thing if you look at a building. So what are the things we have touched? Come to the right hand one, building envelope. We talked about building envelope to maximize the light admittance and minimize the heat admittance and increase natural ventilation and natural lighting. Number two, mechanical systems. In every building, the major building mechanical system is the HVAC, heating, ventilation, air conditioning system. That has to be efficient. And mechanical system other than HVAC, so there plumbing is actually we say MEP, and elevators, escalators, boilers, whatever it is. Boilers will come in the hospitals and hotels. Then lighting, very important. Water heating, very important. Electric power, that means when your substation, that is a transformer down, cabling, you are metering everything. Then renewable energy integration. All these things are addressed in the Ecbc. Now let us move to the next slide, please. Slide number 13. When you are talking about the first component, that is the envelope of a building, the most important thing is how much light, how much ventilation, how much heat my building is going to gain from the climatic conditions outside. How should it behave? So we should know which climatic zone our building is going to be situated. If you look at the National Building Code, the latest one is 2016, it categorizes India into different climatic zones. So if you look at Kerala is like a hot and humid. Like I've given some example like Kolkata and Kerala almost say you can say hot and humid. If you go to Bangalore, it's moderate. Shillong, it is cold. Delhi, it is composite. Extreme temperature in Delhi. So what is the meaning of this particular climatic zone and our building design? a building designer has to look into the climatic zone to decide his building envelope, his ventilation, his what do you call that, the heat gain calculations, etc. But when you look at it, generally, if you look at this Kerala as hot and humid, there are microclimatic variation. We can see even if Kerala is hot and humid, Idukki and Wayanad, and you can see the coastal area, Kannur or Calicut or Trivandrum, all are different. So that's called the microclimatic aspects, what can be incorporated in the building. It depends upon the design, how you will accommodate it. Because some of them you may have to take, even Idukki we have got hot day, very hot climate season. So how do you do that? You take the general climatic condition, then you have to go for building controls like your HVAC control, illumination control, natural ventilation to fine tune to suit the climatic conditions. So here the heat gain through walls, the fenestration, climatic zone, these are humidity value. Humidity also very important factor. You know, your water barriers, etc. In Gulf country, if you design, we have got a problem like dust loading. All the windows we allowed what you call the sand traps, etc. So climate effects. Next slide, please, number 14. So Ecbc is looking at some figure to optimize the energy consumption of a building. What is that? That index is called Energy Performance Index. Very easy to calculate. If you take your building and its carpet area, put it there, take the total consumption of energy for the building, put it there for a year, and KWH, energy consumption per year divided by total meter square, is your EPI. So if you calculate that per month, per year, etc., you will get the variation. And this figure is the one which speaks how efficiently your building is designed, constructed, and operated. And this is the index you are going to optimize in your Ecbc compliant design. So mathematically, if you write it, EPI is when you talk about the energy, you take all the energy used there, not only electricity. Suppose you go to LP, any commercial energy you should use, not the renewable, that KWH figure. And you know, every energy can be turned into 1 unit. So it's a function of your U value, means the insulation, the conductivity of your envelope. Resistance means the insulation property of your walls, windows, etc. Walls and roof, etc. Then KWH per TR means is an example for an appliance system efficiency. How much kilowatt per ton of refrigeration you are using. Then LPD means light power density. When you are inside the building, suppose you are in a software park inside a room, you need a particular amount of light, say for example 150 to 200 lux on your working table with good uniformity, so that when you look outside you should not feel, when you next table you should not feel dark. So with uniformity. And for that, how much energy you are using is what's called the less power density. So for example, I need 200 lux in the working plane. For that, how much power I am using, that is LPD. It is technology neutral standard value. So it depends upon what sort of technology, like LED or what you are using. LPD can be 0 when you are using full daylight to illuminate an internal space. Then efficiency equipment, whether it is a geyser or a computer or a pump, efficiency equipment, then efficiency system, the whole system design. So these are the parameters we try to play with in design optimization in Ecbc to be complied with, and in turn for EIA or in Graha or in Green Building Code. That picture gives you a very speaking figure, how the radiation comes, how the reflectance come, how internal energy is generated, how natural energy, etc. The picture is speaking itself. So go to the 15th slide. Next slide, please. So this is a bit complicated, but it is comprehensible. So when we talk about the Ecbc, I am already again repeating, we are talking about the applicable components in Ecbc are building envelope, puram chatta, building in the puram chatta, wall, roof, windows, doors, whatever it is. Then comfort systems and control, HVAC control, lighting controls, etc. Then electrical system, renewable energy systems. These are the components where Ecbc is looking into. And in the standard, there are certain mandatory things you have to do. Like I told you, for example, 20% hot water should be only from what you call that solar water heaters. or your minimum LPDs would be this much. Like that, there are a lot of mandatory depending upon the envelope, HVAC, lighting, etc. That has to be adhered to, minimum value. When you come to the required for all compliance method, you need mandatory, nirbandhamaya meet cheyenda കാര്യങ്ങൾ, you have to do it. Then come to the right side, we have got a prescriptive method. What is prescriptive? If you don't use an insulation for the roof, you can have some sort of plantation. If you are not using Skylight, you can go for some sort of top level, what you call the ventilators. So such perspective given in the code can be adopted. If not one, another one. That is another one for the envelope. You can go trade-off. If you don't use one method, you can use other method. Trade-off method. It's given what sort of trade-off. Then you go for a whole building performance. Each component, whatever is in the Ecbc, you optimize using mandatory compliance plus prescriptive method. Prescriptive what means? It means, suppose you want to reduce your body mass index or your weight. Doctor prescribes something, you can do something. There are some prescribed, your calorie intake should be this, blah, blah, blah. Any of these methods you can adopt. You can either walk more or go to the gym. Prescribe any of them you can adopt. That is prescriptive method. In the whole building performance method, all these values you add together, calculate your EP and try to play with. Your objective is to minimize the unit of energy used per meter square of the building. Achieve with this whole building performance and complete your design. That's it. That's how you design a Ecbc compliant building. There are a lot of Ecbc certified personals in India and also a lot of people in Kerala also. You can consult with them, but before going for consultation, try to read these codes and try to comprehend. So next slide, there's 16 the slide, please. So 16 slide, can you see that? This is a case study actually. A normal building design has a EPI of 200 units per meter square per year. There's a normal building, nobody consulted with Ecbc. But the Ecbc consultant or designer optimized the envelope. They went for a cavity wall with insulation. So the heat gain is reduced. They gone for an insulation and shading of the roof. They go for double glazing windows, improved the solar heat gain coefficient of the system. With these measures, he could bring down the 24208. Then he went to optimize the lighting system. He integrated the daylight with an efficient fixture and lamps. How do you integrate? Some of the buildings, particularly in some of the classrooms, you can see the window side things, there will be lower light. In the medial, there will not be, and the end it will be. So how you can integrate it with the control system and do it, and the dimmer facility, etc., or whatever possible. There are a lot of design packages. A lot of companies, lighting companies, are offering a lot of solutions. So with that, he could bring down 208 to 168. Then he touched the HVAC. So what he did, every load has been optimized. The base start from the bottom. Then chiller efficiency, condenser, then building automation, everything is incorporated, and he could bring down that to 133. Then he incorporated something called the total building automation system. That means centrally you can control everything in the building, from natural light to its ventilation, everything. So that control also he added. That is the fine tuning with even microclimatic conditions. The 240 has been brought down to 98. Believe me, we have done this type of simulations. 40 to 60% reduction for a conventional design is possible. But you have to also operate the building accordingly. So there's a huge potential by incorporating Ecbc in our design. Next slide, please. In the next slide, that is slide number 17, you can see the impact of Ecbc in our country. This graph is very comprehensive, prepared by Bureau of Energy Efficiency, compiling the data from all states. You can see here the y-axis, the climatic zones, cold, climate, composite, hot, dry, moderate, warm, moderate. In all these places, what are the type of reduction in the EPI? We could realize something like 20-25% depending upon the typical building and Ecbc building. This entailed a savings around 20-25% in building energy consumption. So when we started preparing this all exercise, we all involved actually, the savings By 2030, we are expecting a minimum of 50%. There's a model actually. This model you can discuss maybe later how we made it. So, but actually we are exceeded this. More than 50% energy saving possible by 2030 in building sector. And you know, building sector consumes almost 1/3, 400-500 billion units of electricity in India. So 50% reduction is substantial. And peak demand reduction around 15 gigawatt. And corresponding carbon emission. This mainly from the electricity consumption, you know, carbon footprint electricity. They can save about 250 million tons of carbon dioxide emission back when we could do, and monetary saving due to all these things around 35,000 crores, and the investment whatever we have to make is months to years it get paid back. So this is the impact of that. Now let us move to the next point in the green building in the slide number 80. That is called the safeguarding the water resources. So water efficiency has to be improved. Whatever water using appliances system, we have to fine tune it. Then efficient and eco-friendly wastewater management. Now even for domestic use itself, you have got recycling units. Some companies are selling it, proven. Or you can have appropriate methods. Then harvesting water for safe use in innovative ways. See, rainwater harvesting is there, even other type of stormwater, etc. Then minimizing water use in building in total. So you can see the picture here, modeled for Department of Energy. Here you can see here, fresh water resources coming to a building. What we do, we treat the water, and because the green products we return it, some of them for the garden landscape purpose, some of even back to the freshwater supply, plus rainwater and other use. So it's called a circulation. So like in a cooling tower, the make of water in a building try to minimize. It's called the zero water concept. You don't have to have water to do it except the evaporation loss. It's an ideal case, but minimize the water use in all these methods is a component in the green building code. Next one. Next one is slide number 19, talking about the wastage, how to minimize the wastage and maximizing reuse. Waste minimization is very important. Like most of the people are now going for a paperless type of concept. And you talk about everything. In one of the huge government houses, once we audited, we have seen the water itself is content is more oil. We don't know whether they wash their vessels or because of the canteen waste. How can we minimize it? We don't know. We are discussing it. So waste minimization, how whatever waste is generated in the building. But in the case of hotels, etc., it is small. In office and mall, it is a different story. Building to building varies. The repair and reuse, we talked about that earlier. This is the latest trend now, not to throw away but try to reuse. The recycle and reuse means what? See, sometimes within the building, whatever you can do, within the campus, whatever you recycle and use, or you have to give it to someone else outside. But these recycle reuse percentages are monitored for certain countries. Some European countries are very clearly monitoring, like auditing. Then energy recovery. Energy recovery from the waste is possible. Simple example is the biogas. Then composting. Obviously, you know, landfilling. So material, fewer and fewer material. There's a dematerialize. If you like, even if some of the building, even the houses, if you conduct a material audit, sometimes 50 to 60% of the material what you have may not be required. And end of life, when you talk about demolition, end of life, or even the electronic equipment, what you do with end of life. Then building users like apartments or even malls are used by different agencies. There will be Kentucky Fried Chicken, there will be Raymond's, there will be some small shops, food court, etc. All of these users should be trained and oriented, lined up for reusing and recycling. That's one of the components. Then number 20. Number 20 talks about health and well-being. So we have already talked about an example, volatile organic compounds in the paint, harmful emissions, any other sort of emissions. Then natural light we already talked about in the case of energy conservation, but not only energy conservation, but the building look itself can change when you make an ambient with nature. We have seen, you can see the first building, how it is being done. It's a glass building, but this glass suits to the HSE stipulations. The designing ears and eyes. What is ear and eye? The acoustic. See, once in one of the hospitals, I have been undergoing the MRI. So the nearby is the canteen. The canteen vessel sound has been making me more panicky than the ding ding song of the MRI machine. So why? Because sound transmission coefficient of the wall separating the canteen and the MRI lab, there is no much of a, it is not STC rated, sound transmission. That's an example I'm giving, but it happens actually. So we have to have acoustics, and also in the auditorium, acoustic itself is energy loss. Then sound insulation plus glare for the eyes. When you say natural lighting, you should ensure that it's not having any glare. Then ensuring natural internal air quality, we have already talked about that. Passive design is a concept where natural things like natural ventilation, natural lightings are used without any mechanical energy device. That is passive design. Then building control and optimization. You can see the bottom figure. That itself we can give a concept how, even like you know very clearly how the fire hydrant, fire alarm system is. Like that you can control everything automatically, manually, semi-automatically, even centralized way, even externally with IoT, etc. So nowadays these are coming more and more. Why are we using this in the green building? For improving the health and well-being and making it more human friendly. Next slide, 21. 21 is talking about how can you make a building very lively, mood, very nice. When we say in a building, we say very nice. Suppose some of the hotel lobby, when you enter first, we'll say, oh, very nice. After a few minutes, you will say, too much problem. Either it's cold or you're feeling tired, the quality of air is bad. So in a biophilic design, what is biophilic? It is relating to the human tendency to interact with the nature. So how do you do that? Suppose you're talking in your own house. Everyone wants to be a house very comfortable. But when you come after work and we say you're sweating, no ventilation, we feel like a jail, what will happen? You see that lady sitting in the lounge, she's very nice. And also you see that figure, how that office area has been laid out, very comfortable. So like this, you can also make your home or your office, your green building mandates to enhance the biophilic design, incorporate what are the features possible. Okay, so next slide please, 22. 22 is talking about environment green. We talk about an apartment here. Most of the apartment is, a compound is filled with the building. No much place to walk around. It is not well connected to the nature. But in some country or some states, it is well done. Even some country. You can see the first figure. Green is our perfect dream. You can see the water body, the walkway, etc. So preserve the nature, protect wildlife, enhance the land quality, even remediation measures. You can reclaim the land. So you can modify the nearby lakes. And we are doing it. It's not that we are not doing, but we should keep the environment green. And urban areas, I call it make areas more productive, bringing agriculture. But mainly it is urban area. Whatever area you are occupying in your campus. Now even we are talking about areas cultivating your vegetables, agriculture, urban forestry, etc. Make it more meaningful. And this is a mandate. There are points under rating system for green buildings under these things. So try. There are possibilities to explore depending upon the geoclimatic conditions. Number 23. 23 is very important. You can say to some extent in green building addresses this, but now we are stressing it more and more. There are a lot of vulnerability assessment is going to take place in most of the places now. So it will state you in the site selection criteria where you can build, where you cannot build. Now we have got green belt only, but vulnerability means it's landslide property and climatic aberration, etc. But even if you take those things, there is a climate resilience we have to do. Let us look at this picture first, then move to the text. Resilience framework, we can start anywhere. First of all, let us talk to the top circle on the blue one. Understand local climate conditions. This is very important. See, when you're talking about the pre-engineered building, pre-engineered building nowadays it's a splash. Long back it's only abroad came, now here also. You engineer the building, just come and assemble it. Even that, I myself was party to construct this type of building abroad. So we give the geoclimatic data very clearly to the designer in the EPC project. Suppose the desert region, how it will be in a climate snowfilling, So that climate data should be very main. Then you have to identify the vulnerabilities and risks and impact of that particular locality. Then formulate adaptation options. Adaptation means what? You have to, your building should adapt to that. Then assess and prioritize options. Then you have to implement measures, then monitor it, then review strategy. So resilience framework move around this particular circle. So building has to have a capacity to anticipate and prepare for all sorts of hazardous events. And it should be able to assess the climatic risks, then factor in these risks in the design operation so that loss prevention is realized, less stress on the people and property. So this is an important component. This is not as important as now in green building aspect, because you know how climate is affecting. Now 24 please. 24 is connecting communities and people. Suppose you've got a big office complex or a university complex or even residential area. You have to connect and enhance the communities. You have a positive economic and social effect. You can see how people will be happy if you can do that. That's important. The distance to amenities. You know, when you have a site selected, how will you commute with the nearby shopping centers, your office, the public places, your railway station? You don't talk about it is near to the place. That's how we used to sell our apartments, only 12 kilometers away to airport, etc. But the connectivity should be possible with minimum stress on environment. How do you do that? It's a challenge. Depends upon the terrain design, topography, building. But this is also a factor. So distance to amenity in design, reduce the impact of personal transport on the environment, encourage environmental friendly options, etc. So this is what's called, this is one of the component in the green building. So next slide please, 25. And this is actually somewhere related with the building automation, but much more than that. In these days of calamity, this ICT, that is information communication technology, integrating with all facilities, you know, whether it is a gated community or a layout or a villa or even malls or offices, it should be get connected with the, suppose I need to call a gas vendor or an electricity supply company or an industrial manufacturing unit or a safety and security. You can see the interconnection, how it has been done. So information communication technology, governance, that is how we manage it, how the economy, environment, society, etc. interconnect. This is a very self-speaking picture, so we don't have to waste much time. Just take it from the utilities, waste, security, healthcare. Everything should be within the envelope of governance, economy, environment, society should be well connected. It's a green building. 26 please. So I will quickly go through a case study which may take care of whatever we learn within another 5-6 minutes before I end my discussion. This is a building IIM Kozhikode. You are familiar, maybe some of you. This is a 5-star Griha rated green campus actually. So 1 lakh meter square, built up area 29,000 meters square. So you can see the energy performance index they could reduce with respect to the conventional building, 66% reduction compared to Griha benchmark. They could reduce the energy consumption, and they are given, now it has been permanent rating 5-star rating has been given in 2019. Next slide please. You can see the picture of the building. Some of you would have seen it. So this is only showing the picture. You can keep this picture in mind when we proceed further. Number 28. So what did they do? The site planning. They didn't disturb much the terrain. I'm not writing the numbers. They tried to maintain as much trees as possible. They could do lot of barricading to avoid air pollution. Then so many facilities like wheel washing facility, other appropriate measures were strictly adhered to during the construction stage itself. So this is the site stage. Okay. Now 29 please. This is a water management. What did they do? See, they are all cross-referring with the Griha base case. From Griha base case, they could reduce by about 59% of water demand by efficient installation of water fixtures, and also they could landscape water demand they could bring down. The internal and exterior water demand would be. Then some sort of columns and ponding technique for curing slabs during construction, etc. Then water demand, reusing the water, treating the water, rainwater collection, they could meet or exceed the target. Then page number 30, slide number 30, water and waste, they could reduce the Griha based rating by 50%, the water demand, and this is water and wastewater. Then they could also reduce around 50% landscape water, they could reduce, and you can see around more than 1 lakh liters of water they could rainwater they could recharge in the pit and reuse it. Number 31, energy optimization detail like digital timers for lighting optimization, EPI reduction, and national building code, they are referred that time 2005, but 20016 is there now. Then they could install some renewable energy panels, the solar water heater system and solar panels. They are trying to increase that capacity now. Then 32 slide, sustainable building materials they use. A lot of the materials like fly ash, bricks, porcelain, cement, fly ash. This can be listed for, I have taken only some examples. So when you are trying to comprehend this particular green building, just give importance to sustainable building materials. So you can move to the next slide, 33, waste management. These are very obvious methods used in many of the offices and hotels, like segregating, recycle, reduce, reuse waste in different bin, etc. So next 34, I think I have taken my time, about 6 minutes or 10 minutes I exceeded. So anybody who wants to know more about this particular thing may refer the following website: World Green Building Council, the United States Green Building Council, then Indian Green Building Council, then Bureau of Energy Efficiency for Ecbc and Ecossamhita, then Griha, you can see a lot of literature, then Ministry of Environment and Forest, and for disaster resilient design, etc., go for National Disaster Management Agency's website. And that's it. Let us try to make our life green in all aspects. Thank you very much for patient listening.
I'm closing the presentation, sir. It's okay?
Okay.
Now it is open for questions, because sometimes the participants can raise or unmute and ask questions.
Someone start. Did you appreciate that we should have more green buildings now or not? That's the first question.
Good evening, sir. I am Sandeep from Ecbc Limited.
Okay.
It was a very nice presentation, and we could learn a lot of information regarding green energy and green buildings. So, how about the green buildings in Kerala, sir?
Kerala is very proactive in the green building. Mostly there are a lot of Icbc rated building now. Ecbc compliance in the design has been already imposed by the Public Works Department as well as the local self-government department. For new buildings more than 500 kW load, Government of Kerala is insisting to comply with the Ecbc code. Ecbc alone won't make the building green, and a lot of customers like big corporates are also coming up. Government sector, PW had already taken that they will implement the Griha green rating system. So you can say there is an increasing awareness as well as impetus from both government side and the private builders now in this. And the statistics you can collect from both the sites, like Griha site and well as the IGBC, in each state how many are coming up. In the case of government buildings, public information by the LSGI as well as the PWD department. So it is progressing.
Okay, thanks.
Another thing is, you all, if you are interested, can get certified as a ECBC certified professional. Some EMC is also operating some program, and so many agencies are, even Griha rating system you can get certified, IGBC you can get certified, etc.
Okay.
Sir, any government policy to go for a green building in government sector? Is that policy is there?
Yes, it is. Like PWD, as I told, Kerala government is already going for adapting the Griha system for the buildings. Kerala government and PWD. And in the case of local self-governments, that is the Punjab Municipality Corporation is not telling about the green as such, they are talking about the ECBC. 2018-17, we have published the ECBC as a rule in the state. That has been implemented. But now, when the disaster resilient things are coming, that's going to get integrated in the green building and going to be a you can say immediately there could be a impetus in the supply. Otherwise, PWD LSD is doing it.
Or for that any support or subsidy or something like from government?
I have seen some notification recently that the building tax reduction, substantial tax reduction has been already there in the discussion. I don't know whether it has been launched as a rule. Government of India, this point has come up, and since it's a state subject, has been left to the state. I think our state government has already made some draft notification on this. Tax incentives.
Thank you, sir.
So even in houses, you can make a lot of, whenever we are doing a renovation for a small hotel or a house, we can try to incorporate a lot of concepts to make it better. And many of the consultants are there who can extend help in this direction. It won't be much costly. Like in government, we are thinking about all the renovation when they do, for the particularly the commercial buildings. We should incorporate all these features as much as possible. For energy efficiency, there are a lot of financing portals like Kerala Finance Corporation, then even Bureau of Energy Efficiency, etc. extending. Even banks are extending if you want to, like SBI, etc. There's a consortium. For details, you can contact Bureau of Energy Efficiency. It is there, operated through some financial institutions.
If any more questions, we got some more time, 5 more minutes to conclude it. If any queries, we can get put also in the chat box. I think no more questions. Shall I conclude?
Yeah, I think so.
Okay, now it is come to the end of a very fabulous learning session. On behalf of the HSE team and all the participants, I extend a very warm thanks and our gratitude to Narayan sir for making a wonderful learning session this evening. It's a very I don't know the ways how to. It was started from the need of the hour, then it come to the background, then concept, and you come to that some case studies and a fabulous experience or examples that's taken through the IAM Kozhikode, how it has implemented in Kerala, a success story. That also, it's a very good learning. Thank you very much for the valuable time with us. Thank you, sir. Thank you very much.
Thank you.
Thank you, sir. And thank you very much for Nandu sir for providing all the support, and our KC team, including me, who has taken a lot of pain to make it happen. Thank you, the entire participant, for the wonderful session. Thank you very much for entire participant. Thank you, sir. Thank you once again.
Thank you.
Yeah, thank you.
Thank you, sir.